Today we're going to talk about fractions. So all fractions are written in the form a over b, where a and b are non-zero integers. An integer is just a whole number like 1, 2, 3, 4. And we require them to be non-zero, especially b, because we're not allowed to divide by 0. If a is 0, then it's just 0 divided by a number, which is just 0. So that's a trivial case. So in general, a will not be 0. And b is not allowed to be 0, because we're not allowed to divide by 0. Examples of fractions are 1 over 2, or a half, 7 over 4, and that's the same as the numerator over the denominator. So a is the numerator, b is the denominator. If a is less than b, we say it's a proper fraction. Example, 1/2, because 1 is less than 2. If a is greater than b, we say it's an improper fraction. Example, 7 over 4, because 7 is greater than 4. So for a proper fraction, the actual fraction value will be less than 1. And for an improper fraction, the fraction value will be greater than 1. Now I want to talk about reciprocals. The reciprocal of a number n is defined as 1 divided by the number n. So the reciprocal of n is equal to 1 over n. So it looks like a fraction. It's written in fractional form. Example, the reciprocal of 5 is equal to 1 over 5, or 1/5. The reciprocal of 2/3 is equal to 1 over 2/3, which is equal to 1 times 3 over 2, which is equal to 3 over 2. Now let me explain what we did there. So the critical step is where we flip 2/3 into 3 over 2. So when you divide by a fraction, what you need to do is you need to multiply it by its reciprocal. So that's the trick. So to get the reciprocal of a fraction, we simply flip the fraction. So example, reciprocal of 4 over 3, or 4/3, is 3 over 4, 3/4. So remember, when you're dividing fractions, when you divide one fraction by another fraction, you need to flip the second fraction and multiply. And that's very straightforward to multiply. Now notice, if we take the reciprocal twice, we get back to the number we started with. Example, reciprocal of 2/3 is equal to 3 over 2. The reciprocal of 3 over 2 is equal to 2/3. So we're back at 2/3. And it would have worked the exact same way if we'd have started with 3 over 2. So in general, the reciprocal of a over b is equal to b over a for any non-zero a and b. This will be useful when we divide fractions. So let's have a couple of examples where we add and subtract fractions. So we'll start with an adding example. So we have 1/2 plus 1/3, and that's equal to 1/2 times 3 over 3 plus 1/3 times 2 over 2. And that's equal to 1 times 3 over 2 times 3 plus 1 times 2 over 3 times 2. That's equal to 3/6 plus 2/6. That's equal to 5/6. So our answer is 5/6. So 1/2 plus 1/3 is 5/6. Now what did we do there? Well, we found a common denominator by multiplying the two denominators together, i.e. 2 and 3. So 2 times 3 is 6. So 6 is our common denominator. Then once the fractions both have the same denominator, we simply add the numerators. So if you look at the last step where we had 3 over 6 and 2 over 6, so they've both got a denominator of 6. So now all we have to do is add the numerators 3 and 2 together to get 5. The same logic applies for subtraction. So we're really just swapping the plus sign for a minus sign. but we need to go through it carefully anyway. So a half minus a third is equal to a half times 3 over 3 minus a third times 2 over 2, and that's equal to 1 times 3 over 2 times 3 minus 1 times 2 over 3 times 2. Again, we have a common denominator of 6, so the last part of the answer is 3/6 minus 2/6, and that's equal to 1/6. Now we're going to look at a multiplying and a dividing example of fractions. Multiplying is probably the simplest case you'll ever meet. When you multiply two fractions together, all you have to do is multiply their numerators and multiply their denominators. So 1 over 2 times 1 over 3 is equal to 1 times 1 over 2 times 3, and that's 1 over 6. Very simple. However, it does get a little trickier when you divide, and this is where reciprocals come in. So 1 over 2 divided by 1 over 3, or a half divided by a third. So what did we do? We flip the second fraction. We take its reciprocal. So that's equal to a half times 3 over 1. When we take the reciprocal, we have to multiply. And that's equal to 1 times 3 over 2 times 1. And that equals 3 over 2. So, if you have two fractions, a and b, a divided by b, you simply flip the second fraction and multiply. Simplifying fractions. Sometimes we can reduce a fraction to its lowest terms. Example, 4 over 10 can be reduced to 2 over 5. Suppose I asked you to compute 1 over 10 divided by 1 over 4. Then 1 over 10 divided by 1 over 4 is equal to 1 over 10 times 4 over 1. All we've done is we flipped the second fraction, we took its reciprocal, and now we multiply. And that's equal to 1 times 4 over 10 times 1, and that's equal to 4 over 10. Which is technically correct, but it's not in its lowest terms. 4 and 10 have a common factor of 2. So we can divide both top and bottom by 2 to get 4 over 10 equals 4 over 2 divided by 10 over 2, and that's equal to 2 over 5. So far we only looked at positive numbers. Negative numbers can be used too, but we need to be careful we get the sign correct in the answer. Example, 2/3 plus minus 1 over 3, or minus a third, equals 2 plus, in bracket, minus 1 over 3, equals 2 minus 1 over 3, equals 1 over 3. Notice when we add a negative number, all we're really doing is subtracting. So 2 plus negative 1 is the same as 2 minus 1. 2/3 times negative 1 over 3 equals 2 times negative 1 over 3 times 3 equals negative 2 over 9. So the 9 is very straightforward, but we just need to be careful with the minus 2 on the numerator. So a positive number times a negative number equals a negative number. So that's why we have a minus 2 there. 2/3 minus a third. Well, that equals 2 minus, and then in bracket, minus 1 over 3. Now, when you subtract a negative number, you're actually adding a positive number. So the minuses, the two minuses, become a positive. So 2 minus minus 1 equals 2 plus 1. So that fraction now becomes 3 over 3, which equals 1. And actually, that is not a fraction. That answer is not a fraction. 1 is an integer. 1 is a whole number. So it's not a fraction. Technically, it's not a fraction. If you write it in the form 3 over 3, it looks like a fraction. You've written it in fractional form. But when you work out the value of the answer, it's a whole number. It's 1. It's not a fraction. And finally, 2/3 divided by -1/3 equals 2/3 times, we flip the fraction, we take the reciprocal. It's times 3 over -1. Just make sure you keep the signs consistent. So the sign of 3 is positive and the sign of the numerator is negative, it's -1. So make sure you keep that on the denominator when you flip it. And that equals 2 times 3 over 3 times -1, and that equals 6 over -3, and that equals -2. And that is a whole number as well. Okay, it's a negative number, but it's still a whole number. So that's not a fraction either. But when you write it in the form 6 over -3, it looks like a fraction. And that's why it's so important that you simplify fractions as much as possible so that the answer doesn't look as complicated. It looks nicer when you just have a whole number like 1 or -2. That looks a lot better than 3 over 3. Wouldn't you agree? So that concludes the video. Have fun with fractions. Thanks for watching and please subscribe.